Before we had computers or even books as we know them, people still needed to save information. Consider this. For thousands of years, the best way to record something important was to carve it into stone. Think about ancient Egyptian hieroglyphs on the walls of pyramids. Each symbol was a piece of data, telling a story or recording a law. These stone tablets were incredibly durable, lasting for centuries, but they were also incredibly heavy and could not hold much information. Imagine trying to carry your school homework around on a giant slab of rock. It was a very permanent, but not very portable way to store knowledge. It was science in action, using the materials around us to save what we knew. Then came a brilliant idea: clay tablets. In places like ancient Mesopotamia, people would press marks into soft clay using a stylus. When the clay was baked, it became a hard, permanent record. This was a fantastic step forward. Clay tablets were much lighter than giant stones and easier to make. You could store many tablets in one place, creating some of the world's first libraries. A single tablet could hold a list of goods, a letter, or a short story. However, they were still quite bulky and could shatter if you dropped them. It was a trade-off: easier to create and store, but more fragile than solid rock. This was humanity's first attempt at a more efficient database. The next great leap was paper, or rather, its early ancestors like papyrus in Egypt and parchment made from animal skins. Suddenly, information became lightweight and flexible. You could write long texts, roll them up into scrolls, and carry them easily. A single scroll could hold the equivalent of many, many clay tablets. This change allowed knowledge to travel like never before. Instead of a heavy stone inscription that stayed in one place, a scroll could be sent across a kingdom or even an ocean. Information was becoming mobile, spreading ideas and stories faster and further than ever. It was a revolution in data portability. But writing everything by hand was slow. To make another copy of a scroll, someone had to sit down and write the whole thing out again, word for word. This is where the printing press, popularized by Johannes Gutenberg in the 15th century, changed the world. Using movable type, printers could arrange letters to form pages and then print hundreds or thousands of identical copies. This meant books could be made cheaply and quickly. A single printed book could hold the information of many scrolls, and it could be shared with countless people. The amount of data available to an ordinary person exploded. Science, literature, and new ideas spread like wildfire, all thanks to a better way of copying information. As we entered the age of machines, we needed a way for them to read information. Humans can read letters, but machines need something simpler. Enter the punch card. This was a stiff piece of paper where information was stored as a pattern of holes. A machine could read the card by sensing where the holes were. Early computers in the mid-20th century used stacks and stacks of these cards to run programs and store data. One card could only hold a tiny amount of information, maybe about 80 characters. That's less than a single modern text message. To run a complex program, you would need thousands of cards, all kept in the correct order. Punch cards were a good start, but they were clumsy. You needed huge stacks of them, and if you dropped a stack, you could spend hours putting them back in order. Scientists and engineers needed something better, something that could hold more data in less space. The answer was magnetic tape. This was a long strip of plastic coated with a magnetic material. Information could be stored on the tape by magnetizing tiny spots in a specific pattern, representing ones and zeros. This was the same basic idea we later used for cassette tapes for music and VHS tapes for movies. It was a huge leap in storage capacity. A single reel of magnetic tape could hold the same amount of information as tens of thousands of punch cards. That's like trading a whole room full of paper for something you could hold in your hands. This made computers much more powerful and useful for big tasks, like processing a company's payroll or performing complex scientific calculations. Data could be read much faster from tape than from a stack of cards. However, tape had a big drawback. It was sequential. To get to a piece of data in the middle of the tape, you had to wind all the way through it from the beginning. It was like trying to find your favorite song on a cassette tape by fast-forwarding and rewinding. This method of storing data was used for decades in large mainframe computers that filled entire rooms. These were the workhorses of government, universities, and big corporations. They used magnetic tape to back up important systems and store massive datasets for research. While it seems slow and old-fashioned to us today, magnetic tape was a critical step in our journey. It taught us how to store vast amounts of digital information magnetically, a principle that would become the foundation for the next wave of storage devices that would eventually find their way into our homes and our hands. It was a truly magnetic moment in the history of science. In the late 1970s and 1980s, computers started to appear in our homes, and they needed a convenient way to store and share data. The solution was the floppy disk. These were square plastic cases with a flexible magnetic disk inside. That's why they were called floppy. An early 8-inch floppy disk could hold about 80 kilobytes of data. That might sound tiny now, but back then, it was enough for a simple computer program or a few documents. Later we got smaller 5.25-inch and then 3.5-inch floppy disks. A 3.5-inch high-density disk could store 1.44 megabytes. That's enough to hold a small book, but you would need about 450 of them to store just one movie. As software and files got bigger, we needed more space. The next big thing was the compact disc, or CD. Instead of using magnets, a CD stores data as a series of microscopic pits and flat areas on its shiny surface. A laser in a CD drive reads these pits as ones and zeros. A single CD could hold around 700 megabytes of data. That's the same as nearly 500 floppy disks. This was a game changer. Suddenly, we could store entire encyclopedias, high-quality music albums, and complex software on one shiny disk. Then came DVDs, which used a similar technology, but could hold 4.7 gigabytes, enough for a full-length movie. While disks were great for moving data around, computers needed a place to store the operating system and all your personal files permanently. This is the job of the hard disk drive, or HDD. Inside a hard drive are one or more spinning platters coated with magnetic material, kind of like a stack of super-fast, super-dense records. A read-write, head on a moving arm, hovers just over the surface of the spinning platters, reading and writing your data magnetically. Because the platters spin so fast, thousands of times per minute, the hard drive can find and access any piece of data almost instantly. This is called random access, and it's much faster than winding through a magnetic tape. The capacity of hard drives has grown at an incredible rate. Early personal computer hard drives in the 1980s might have held 10 or 20 megabytes. Today, it's common to have a hard drive that can store several terabytes. 1 terabyte is a million megabytes. That's enough space to hold hundreds of high-definition movies or millions of photos. This massive increase in storage capacity, combined with the speed of random access, made modern computing possible. It allows you to have all your programs, games, photos, and videos right there on your machine, ready in an instant. It's all just physics and engineering working together. Now, we are in the era of the cloud. But what is the cloud? It sounds mysterious, but it's really just someone else's computer. When you save a file to the cloud, you are sending a copy of it over the internet to be stored on massive servers in huge buildings called data centers. These data centers are filled with thousands and thousands of powerful hard drives and solid-state drives, all working together. They have backup power systems and high-speed internet connections to make sure your data is safe and available whenever you need it. So, the cloud isn't floating in the sky. It's very much on the ground, in a very big, very secure building. The beauty of cloud storage is that it feels almost limitless. Services like Google Drive, iCloud, and Dropbox allow you to store terabytes of data without having to own a physical hard drive for it. You can access your photos, documents, and music from your phone, your laptop, or any computer in the world with an internet connection. This has completely changed how we work and live. You can start writing a document at your desk, add a photo from your phone on the bus, and finish it on a tablet at a cafe. The data isn't tied to one device anymore. It follows you wherever you go. Let's compare the scale. A clay tablet might hold a few hundred words. A printed book, maybe 100,000 words. A 1.44 megabyte floppy disk could hold a couple of books. A 700 megabyte CD could hold a small library of about 500 books. A 1 terabyte hard drive can hold 250,000 books. And a cloud data center? It can hold exabytes of data. An exabyte is 1 billion gigabytes. That's more books than have ever been written in the history of humanity, all stored in one place. The scale is simply mind-boggling. It's a testament to how far our science and engineering have come. From carving stories onto stone to uploading our entire digital lives to global networks, the evolution of data storage has been an incredible journey. Each step, from clay to paper, from punch cards to hard drives, has allowed us to store more, share more, and learn more. It has made information more accessible, more portable, and more durable than ever before. This constant innovation has not just changed how we use computers, it has fundamentally changed how we communicate, how we do science, and how we remember our own history. And the best part? The journey isn't over.